Hello everyone, in the previous video we have learnt how to find out the value of a determinant by different two methods, that is by expansion method and by series method. In this video we will learn the applications of the determinants in two-dimensional coordinate geometry. Before that we should know that a determinant can also be represented by capital D or delta. Now how to apply and for what we can apply the determinants in two-dimensional coordinate geometry. In this video we will take number 1 to find out the area of a triangle if the coordinates of its vertices are given to us. Then we will learn how to find out the collinearity of 3 points which are lying in the same plane, whether the points are collinear or not. This also we can do by the help of a determinant. Next we will have to find out the equation of a straight line passing through two given points. That can also be done by applying the determinants. And next is to find out whether three straight lines are concurrent or not. To find the area of a triangle if its vertices are given to us. Suppose there is a triangle ABC and the vertices of this are x1 y1, x2 y2 and x3 y3. In coordinate geometry we have already learnt how to find out the area of this triangle by using the formula area of triangle ABC, that is half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. If we make a determinant delta which is half of, we take all the three x coordinates in first column x1, x2, x3. All the three y coordinates in the second column y1, y2, y3 and the third column we take all 1. If we find the value of this determinant, is it coming as we are expanding along column 1? That is x1 into, you can say here this will be y2 into 1 minus y3 into 1 minus x2 into y1 into 1 minus y3 into 1. We have already learnt how to find out the value. Then plus x3 into, leaving this column and this row, y1 into 1 minus y2 into 1. If we simplify this, this is half into x1 into y2 minus y3. If we take minus common from this, this will be plus x2 into y3 minus y1 and plus x3 into, this is y1 minus y2. Are we finding the same value here? It means we can find out the area of triangle ABC by applying this determinant. The only thing we have to remember that this determinant is to contain all the x coordinates in the first column, all the y coordinates in the second column, and in the third column every element is 1. Let's discuss one of the example based on this. Find the area of triangle ABC if A is 2, 3, B 3, minus 1 and C 8, 3. So we have been given the vertices of triangle, that is A is 2, 3, B is 3, minus 1 and C is 8, 3. And hence we can find out the area of triangle ABC by using the determinant, that is half into the x coordinates x1, x2, x3. Y coordinates y1, y2, y3, 1, 1, 1. And we substitute the values half all x coordinates 2, 3, 8. All y coordinates 3 minus 1, 3, 1, 1, 1. And then we can find out the value of this expanding along row 1. It will be 2 into leaving this row and this column minus 1 minus 3. Minus 3 leaving this column and this row, 3 into 1 3 minus 8 into 1 3 minus 8. Plus 1 into leaving this row and this column, 3 3 are 9 minus minus plus 8. Simplifying, we get half into minus 4 into 2 minus 8. 3 minus 8 minus 5 into minus 3 plus 15 and plus 17, which is half into 17 plus 15, 32 minus 8, 24, which comes as 12 square units. So we are finding that the area of triangle ABC whose vertices are given here, that is 12 square units. If we discuss about the 3 points in a plane which are collinear, the meaning of that is, if we have any 3 points A, B and C, the coordinates of which are x1, y1, x2, y2 and x3, y3. These 3 points are collinear. It means they don't form a triangle. But if we assume that these 3 points are forming a triangle, then can we say that the area of triangle ABC will be 0? The same condition we apply here. This we have already discussed in 2-dimensional coordinate geometry also. So we say if 3 points ABC are collinear, then area of triangle ABC is equal to 0. It means the determinant half into x1, x2, x3, y1, y2, y3, 1, 1, 1 will be equal to 0. If we multiply this 2 onto the right, it will be 0. It means only if the value of the determinant x1, x2, x3, y1, y2, y3, 1, 1, 1 we find is 0, we can say that the points are collinear. Let's discuss one of the example based on that. That is, check if the points 2, 3, 0, 5 and 7, minus 2 are collinear. For the solution, we name these points. That is, let A be 2, 3, B 0, 5 and C 7, minus 2. What is the area of triangle ABC, or generally the value of the determinant? If we go for determinant only, we can say delta x1, x2, x3, y1, y2, y3, 1, 1, 1. Substitute the values. That is 2, 0, 7, 3, 5, minus 2, 1, 1, 1. Expanding along row 1, we find the value, that is 2 into leaving this row and column, 5 into 1 5 minus minus plus 2 5 plus 2, minus 3 into leaving this column and this row, 0 into 1 0 minus 7 into 1 0 minus 7, plus 1 into leaving this column and this row, 0 into minus 2 is 0, minus 7 into 5, minus 35. This gives us 2 into 7, minus 3 into minus 7, plus 1 into minus 35. Is it 14 minus minus plus 21 minus 35, which is equal to 0. And then we can write, since delta is equal to 0, this implies that A, B, C are collinear points. So like this we can find out whether the points are collinear or not by applying the determinant. Let's discuss one more example on collinearity of points. Sometimes we are given this type of problem: find k if the points 3, 1, 5, 7 and k, 4 are collinear. What we do in such problems? We will apply the condition of collinearity. We can write the points first of all. Let the points which are given to us A 3, 1, other point suppose is B, that is 5, 7, and the third point is suppose C, that is k, 4. Then we know if A, B, C are collinear points, then delta, that is x1, x2, x3, y1, y2, y3, 1, 1, 1 is equal to 0. Substituting the values, we get here 3, 5, k. Y coordinates 1, 7, 4 and 1, 1, 1 is equal to 0. Expanding along row 1, we get 3 into 7 minus 4 minus 1 into, leaving this row and this column, 5 minus k plus 1 into 20 minus 7k is equal to 0. Simplifying, 7 minus 4, 3, 3, 3 are 9 minus 5 plus k plus 20 minus 7k equal to 0. Simplifying this, 9 minus 5, 4 plus 20 is 24. K minus 7k minus 6k, if we transpose, this is 6k. And hence we get k equal to 24 upon 6, that is 4. So we get the value of k as 4 if these points are collinear. We can also find out the equation of a straight line passing through two given points x1, y1 and x2, y2 by applying determinants. How it is done? See, we have already been given 2 points. Suppose A is x1, y1 and B has been given as x2, y2. And we take a point P on the same line. Let P coordinates x, y, be a point on line AB. Then do we find that all these 3 points are collinear? This implies that P, A, B are collinear points. And then for the collinearity, area of triangle will be 0, or we can make use of the determinant which is to be 0. This implies that the determinant x, x1, x2, y, y1, y2, 1, 1, 1 equal to 0. Expanding this particular determinant, we can find out the equation of the line. Expanding along first row, we can find here x into, leaving this row and this column, y1 minus y2 minus y into, leaving this row and this column, x1 minus x2 and plus 1 into, leaving this row and this column, x1 y2 minus x2 y1 equal to 0. This gives us the equation of the line passing through these two given points. We can understand this with the help of one of the example. The example we discuss here is find the equation of the straight line joining the points 2, 5 and minus 3, 1. For the solution, we write these points first: A 2, 5 and B minus 3, 1. And then we write the same thing. Let P, x, y be a point on line AB. This implies that P, A, B are collinear points. This implies that the determinant x, x1, x2, y, y1, y2, 1, 1, 1 is equal to 0. The condition for collinearity of these 3 points. Then substituting the values we get x, y, 1 in the first row, second row x1 is 2, y1 is 5, 1, third row x2 is minus 3, y2 is 1 and 1 is equal to 0. Expanding this along row 1, the first row, we get here x into, leaving this row and this column, 5 minus 1. Minus y into, leaving this column and this row, 2 minus minus plus, 2 plus 3. Plus 1 into, leaving this column and this row, 2 minus minus plus, 15 equal to 0. On simplification we get 4x minus 5y plus 17 is equal to 0. This is the equation of the line joining these 2 points. This is the answer. We can also apply determinants to find whether 3 given straight lines are concurrent or not. But before going to this, let's learn what are concurrent lines. We already know what are concurrent lines, but let's revise it. Say any 3 or more straight lines which intersect at a common point are known as concurrent lines. Like here we have AB, CD and EF. These 3 straight lines are intersecting at a common point P. So these are concurrent lines. And this point P where they are intersecting each other is known as the point of concurrence. Now suppose we have 3 straight lines A1x plus B1y plus C1 equal to 0, A2x plus B2y plus C2 equal to 0 and A3x plus B3y plus C3 equal to 0. These 3 lines are concurrent if the determinant with the coefficients and the constant term is equal to 0. That is, if determinant delta, which is A1, A2, A3, B1, B2, B3 and C1, C2, C3 is equal to 0. The determinant is formed by taking the coefficients of x in the first column, coefficients of y in the second column and the constant terms in the third column. If this is 0, then we say the lines are concurrent. But remember that by this particular method we can find out whether the 3 lines given are concurrent or not. But we can't find out the point of concurrence. To find the point of concurrence, we have to find the solution of these 3 straight lines. Let's understand this also by taking one of the example. And that example is, examine if the lines 3x plus 2y minus 8 equal to 0, 4x minus y minus 7 equal to 0, x minus 3y plus 1 equal to 0 are concurrent. See, if we find the solution of these 3 equations, we are finding x equal to 2 and y is equal to 1. It means there is a common point 2, 1 through which they are passing. It means the lines are concurrent. Algebraically we can find out. But we have to check it by applying one of the determinant. For the solution, what we do, we consider these lines as 1, 2 and 3. And then we go for the determinant. We write for the given lines delta, that is A1, A2, A3, B1, B2, B3 and C1, C2, C3. Substituting the values we get here 3, 4, 1, 2, minus 1, minus 3, minus 8, minus 7 and 1. Expanding the determinant along row 1, we are getting 3 into leaving this column and this row minus 1 minus 21. Minus 2 into leaving this column and this row 4 plus 7. Minus 8 into leaving this column and this row minus 12 minus plus 1. Simplifying, we get minus 22 into 3 minus 66. 11 into minus 2 minus 22. Minus 11 into minus 8 plus 88, which is minus 88 plus 88 or equal to 0. Now the value of the determinant is coming as 0, so we can say the lines are concurrent. So we can write, since delta is equal to 0, this implies that the lines are concurrent. So like this, determinants can be applied to find different problems in two-dimensional coordinate geometry. In the next video, we will learn about the properties of determinants. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.